Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. You have some information about my video channel and about seminars and study manuals. I teach this online seminars for exams PFM, IFM, and LTAM through Illinois State University, and I wrote study manuals for exams PFM, IFM, and LTAM, which are available at these websites here. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. And this is the problem for today. It's problem number 3 from multiple choice section on the last and the first ever exam LTAM from October 2018. For a double decrement model, you are given one in its associated single decrement table. Decrement 1 is uniformly distributed over each year of age. Decrement 2 occurs at exact age x plus 0.75 for integer age x. 3. Q prime 51 is equal to 0.02. So that's the probability of dying within a year of dying from cause 1, so being removed from the population by cause 1, in the associated single decrement table. You know what I call this? I call this the Brad Pitt in a skirt, so Achilles probability. Only one thing can kill you, it's cause 1, or decrement 1, and in that world in which only decrement 1 can kill you, the probability of dying within a year for a 50-year-old is 0.02. And the same for decrement 2, for the same age, is 0.10. And what we're being asked to calculate is 1,000 times Q50, 1, which is 1,000 times the probability of dying for a 50-year-old, but observed, not in that world in which only one cause kills you, but in the real world in which all causes compete. So it's the observed probability of dying within a year for age 50 from cause 1, or not necessarily dying, but being removed from the population. And if you multiply it by 1,000, by the way, this is basically how many people from initial population of 1,000 are visibly observed to be removed from the population due to cause 1. That's basically what we are being asked to find. And here's the solution. And if you study my study manual, you know that I like the apposite body count. Just count the dead bodies. We are asked for the observed probability of dying, so that's how many people were seen to die from that cause 1 divided by the number of people in the population at the beginning. But because we multiply by 1,000, it's effectively like saying 1,000 people start out, how many of them are observed during the year to have died from cause 1 or have been removed from the population. Okay, so let's just count the dead bodies. Let's assume that's what I call the apposite body count. Apposite means precise. It's like what an actuary is supposed to be. So you're supposed to be apposite. So let us assume 1,000 people start out, and decrement 1 is the only one that operates between ages 50 and 50.75. And the associated single decrement table probability of dying within the year is 0.02, but only that decrement operates until age 0.75. And since the decrement is uniformly distributed, 0.75 Q prime 50 upper 1 is 0.75 times Q prime 50 upper 1. That's the defining property, that should be the defining property in your mind of what UDD means. The subscript in front becomes a coefficient for Q, of course. And that is in turn 0.75 times 0.02, so it's 0.015. Well, that means that out of the 1,000 that start out, 0.015 times 1,000, so 15 are whacked by decrement 1, and then 985 remain at age 50.75. And then at exact age 50.75, since Q50 prime upper 2 is 0.10, and decrement 2 operates at this time only, 10% of those 9,885, which is 98.5 people, are taken out by decrement 2, leaving 886.5. And then between age 50.75 and age 60, only decrement 1 operates. And we need to count how many people are whacked by decrement 1 between those two ages. And it would seem, oh, it's a quarter of a year, so it's just a quarter of the total probability. No, you need to be careful because you need to make an adjustment for the fact that some people have been taken out by decrement 2. And here is that adjustment precisely. So, we're looking for 0.25 Q prime 1 upper 1 50.75. Okay, you can write this in terms of the population, L, or P. It's the same thing because we're looking at the probability of survival. So think about it, it's roughly the same as saying number of people who are taken out by decrement 1 between ages 50 plus 0.75, so 50.75, and 50 plus 1, or 60. I'm sorry, not 50 plus 1 is 51. It's not 60. My apologies. So, how many people are taken out between ages 50.75 and 51? Why do I want to say 60? I don't know. There's a difference between 1 and 10. Strange. My apologies. So 51. And of course, if you subtracted the size of the population and then divided by the initial population, we would do this at the top and the bottom. Might as well just work with probability of survival. So this is 0.75 p prime 50 upper 1 minus p 50 prime upper 1. And of course, remember that the second expression really has a 1 in front of p as a subscript, but we drop it, we ignore it, because that's the standard actuarial notation. And at the bottom, we have something like the initial population, but it would be adjusted for the population. But anyway, the bottom is refers to the size of the population at age 50.75. So probability of survival from age 50 to 50.75 with respect to decrement 1 operating, being the only one who operates. Okay, so that's the top. We can just write each of the p's as 1 minus q, and when we do this, subtract 1's cancel, and the top becomes q prime 50 upper 1 minus 0.75 q prime 50 upper 1, and you know why I did that, so that I can put 0.75 in front from a subscript, and the bottom is 1 minus q, and again the same thing. So I'm doing that, and I'm putting 0.75 as a coefficient from a subscript, which is the UDD property. You have to memorize things for actuarial exams, but UDD, what is the memorization of the UDD? The memorization is to remember that the subscript in front of Q becomes a coefficient in front of Q. That's really the key memorization. Okay, so the top now is 0.25 Q prime 50 upper 1 minus, divided by 1 minus 0.75 Q 50 prime upper 1. And we have those numbers. We just plug them in. So this is 0.25 times 0.02 over 1 minus 0.75 times 0.02. So it's 0.005, which would be naively the the probability if we didn't account for the fact that we're doing this for people who are already, we're starting out in this calculation from age 50.75. But anyway, so that top is the naive first estimate, but it's incorrect. You have to adjust for the size of the population at age 50.75, and the bottom does that effectively by accounting for the probability of survival to that moment. So it's 1 minus 0.75 times 0.02, so it becomes 0.005 divided by 1 minus 0.015. So this is 0.005 divided by 985. And I like fractions instead of decimals, so I wrote it as 1 over 197. And that probability multiplied by the number of people available to be whacked by decrement 1 in that period of time, which was, what was it? We just calculated a moment ago, 886.5. So this times 1 over 197. Oh, that's 4.5. It's a very nice number. 4.5 people. In total, therefore, decrement 1 visibly observed by us removes 15 people in the first 3 quarters of a year, and then 4.5 in the last quarter of a year. So that's total of 19.5 people out of 1,000 initially in the population. Well, that's exactly what the problem is asking us to find. So 1,000 times Q 50 upper 1 is 19.5, answer C. This was a very nice problem for using apposite body count. If you understand what's going on here, you know what apposite body count is. And look, you don't really have to memorize any formulas. You just count dead people. What a wonderful approach. You should do it. Answer C, anyway. Okay, this is copyrighted material. Please remember that. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.